I've been working a lot with AMQP, specifically RabbitMQ recently at work, and I was kind of curious, what does Zig's landscape for working with AMQP look like? So let's take a look. We're going to explore that today. So I've done a little bit of research already, and what I found is, please enjoy the dark mode GitHub, since everyone seems to think this is more legible somehow. I don't know how. Yeah. Okay. Let me make this a little bigger so it actually is quite legible. So I found a couple interesting things. So if we go to GitHub, we'll end up back here in just a second. If I go to GitHub and I search for, if we search for AMQP, and there's tons of stuff that comes up, which is cool. But if we add lang-zig, we only get a couple options. So looking at these, this one seems to be potentially the most promising at this point in time, and we're going to explore this library. But one of the things I really want to mention is that we can also use any C library for working with AMQP. My suggestion, after just noodling around with this a little bit, would be to, if you're building something that needs to be production ready, I would probably not recommend this library at this point. In fact, I think they even say that in the README. And I would probably look at building against the C library. But I kind of want to support Zig-based products with a little bit of Python. And, you know, I'm sure there's plenty of stuff out there on that C library, probably through using it through C, not maybe Zig. But the point being, I really want to provide more visibility to native Zig solutions. I think that's cool. I think that's the way that we probably should try to go. The C interop helps us, you know, establish ourselves in that domain, and then we can start to peel away pieces of the C library as we rewrite them in Zig. But we also have this, which is pretty cool. So we're going to do a couple different things. They have a really simple example here. We're going to take this and we're going to make it a little more complex. We're going to put together a Docker compose file as well. So hopefully this is legible. I've got an empty directory here. I'm going to do my usual ASDF set zig 014, and then I'm going to do a zig init. This is going to create my build.zig, my build.zig.zon, and some more stuff. So we know that we're going to want to add our add that dependency to our build.zig.zon. So let's do that. So we should be able to grab the, I always forget how to, yeah, this one, adding dependencies with Zig fetch. Always forget the command for git. Okay, so it's git plus and then the repo. So we can grab this, come back here. We just need to update this because we're not pulling in Discord Zig. We're instead pulling in Alchem still Zig AMQP head. Oops, protocol error. I think I have an extra slash there. Unable to discover remote Git server protocol error. GitHub.com missing the L. Malcolm. Okay, cool. So it resolved that. We should be able to see that in our build.zig.zon at this point. There it is right there. There's a hash as well. All sorts of fun stuff there. Looks good. We also need to add that to our build.zig. So let's go ahead and start there. So we'll start with our build.zig, and we're actually going to do a couple things here. So we're going to produce 2 executables. So maybe this will be a fun little adventure for people who haven't done much customizing with their build.zig yet. We'll keep a lot of this the same. We don't need this library module anymore, so we're just going to go ahead and remove that. And we are, let's go ahead and remove all this too. Sure, we'll just clean out the entirety of the build method at this point. Okay, cool. So we have target and optimize. We'll keep those because we'll use those. So we're going to go ahead and define AMQP dep. We're going to go ahead and define that dependency here. So that'll be a B dependency zig AMQP. And then we need to give this a target, which is going to be a target. And optimize is going to get optimize. Simple enough. Missing a semicolon. Let's add that. Okay, so now let's go ahead and create our first executable. So we're going to create a producer and a consumer with this module. So we'll have Zig writing messages across Rabbit. We'll have Zig reading messages from Rabbit. It'll all work out in a very fun Zig fashion. So we need to give this a name. I'm going to call it producer. Need to give that a comma at the end. Give it a root source file. This root source file. This doesn't exist yet, so we'll have to create this. So it's going to be a b.path to source producer.zig. Also target, optimize. We'll just pass those along. Okay, feel pretty good about that. We can take our producer exe, get the root module, add an import, and make sure that our AMQP module is available. So we're going to bind that dependency specifically the AMQP module. Okay. We're going to do the same thing here for the consumer. So I'm just going to go ahead and we'll yank 8 lines, come down here and paste. Change this to consumer exe. Change this to consumer. Come over here, change this to consumer. Should be good. And we'll do the same thing down here. Change this to consumer exe. Okay, cool. So we have our exes. That feels pretty good. We probably need to add a b.install artifact. And we need to install producer exe, b.install artifact, consumer exe. We can add some run steps. It might be useful. It's probably a good practice to get into. So we could do b.add run artifact, producer exe, const run consumer is equal to b.add run artifact. And this one will be consumer exe. Okay, so our build's coming together. You know, if we pass in args to this, we can do b.args, something like this. Run producer.add arg. Add args, there we go. Run consumer.add args as well. Pass those args in like that. Sorry, I realized we were spending a fair chunk of time on our Build.zig, which maybe isn't the most interesting thing if we're talking about Rabbit, or if our goal has been to talk about Rabbit, but we're almost done. We also, let's see, we also need to make sure that we have a run producer step, which is a B step, and it's called run producer. Give it a description, which is run the producer. This is nice too, because this will help show up in our help. So if we, give an invalid command or we need to ask for help, these will show up and help hopefully highlight some of the things that can be done. Once we've defined that step, we probably need to run producer step, depend on run producer dot step. Let's not forget our ampersand there. And then I will yank these 2 lines, paste these 2 lines, and change word to do run consumer step. Again, change word here, consumer, and this one will be consumer. Come down here and change this from run producer to run consumer. Interesting that that all counts as one word. Run consumer step. There we go. Okay, so if we write tests, we'd want to add some test steps here. For the sake of this video, this is probably going to be a long one. We're going to skip tests for this. So feel pretty good about this. In theory, Zig build should error because it can't find our files. Is that why it errored? Let's find out. No dependency named. Oh, okay. Build.zig.zon. What did it list this dependency as? AMQP. What did I type it in as in our build.zig? Oh, interesting. I called it Zig AMQP. It's just AMQP. Okay. Now it should blow up because we don't have those files that it's trying to load. Source consumer file not found. Perfect. Okay. So let's actually build those pieces, right? So that's going to be the interesting piece. So we can start with the consumer. We can start with the producer. Let's start with let's just do the producer. I feel like that might be the more interesting. Okay. So let's source producer.zig. We have a lot that's going to go on here. So we're going to have standard library. Go ahead and import our standard library. We're going to get AMQP, which is also going to be an import. This one's going to be AMQP, since that's what we bound it to. I'm just going to go ahead and I've kind of taken a liking to this, taking standard debug print and just binding it to print. With that in mind, we can take a look at some of the examples here in the library. We're going to make these a little more involved because these examples are really simple, which is great. It's great to see how you can use it. So you can see that there is an RX memory and a TX memory that's defined here. Those get passed into amq.init. We'll probably do the same thing there. Parse an IP address. Sure, we'll do the same thing there. The part where it's going to get interesting, though, is when we actually start to publish. We'll work with like actual, like a full message struct, I guess. So yeah, let's do that. Okay, so we'll follow that same pattern with RX memory. We'll give it a size like 8,192. It's going to be U8s. And we can just set it equal to undefined. I'm going to yank this, come over here, paste it, change this to TX memory, and we'll do the same thing for TX memory. So we have those two fields. I'm going to hard code a little bit here. You could make these environment variables or something too if you'd like, and in fact, you probably should. But again, one of the benefits of me doing this for you on YouTube is I don't always have to do those things. But if you're making this like a production app, you probably should make this configurable from your environment variables. So we define our host, we define our port, which is going to be, I'm going to give this a type too. It'll be a U16, I guess. 5672 is the default Rabbit port, if I remember correctly. Work with a Q name. So it'll be something like const U8, and maybe we'll set it equal to Zig tutorial Q, something like that. Feel pretty good about that. Okay, so this is our producer. So let's also give it like a const interval seconds. Make this a U64, and I don't know, let's just set it to 2. The idea here is we essentially want to sleep a little bit, so we're not just sending a ton of traffic over our queue. Make this a little more realistic, and we'll send a message, wait 2 seconds, send another message, wait 2 seconds, send a message, wait 2 seconds. We'll kind of keep that going. Let's go ahead and define our main. So we have a pub fun main, just like usual. I might gloss over some of the fundamental Zig things at this point. If you're subscribed to the channel and you've been watching, you probably know how to build a main method in Zig. So we'll just talk through some of the more interesting pieces as we go. So we could print some stuff here that might be useful. So you might want to print like RabbitMQ, and we might want to print like a string here and a digit here. Give these some args, so maybe something like the host. So RabbitMQ host, RabbitMQ port, something like that. And then we may want to print the queue, might be useful as well. Maybe not. It's kind of up to you at this point, what is and is not useful. I like the idea of printing the queue name as well. So when we boot this up, it'll tell us what it's trying to connect to. We're going to also create a variable here called message count. We'll set this to a U64. It'll be set to 0 by default. And the idea here is essentially we need to generate something unique about our messages so it's clear that it's actually sending them like we would expect and not sending the same message over and over again. So we're just going to append a number to our message body. Okay, let's make that connection, right? So this is where it starts to get interesting. The AMQP pieces at least. So using this library, it's amqp.init, and we pass in our RX memory and our TX memory. From here, we need to get an address, right? So I'm going to call this just adder, and I'm going to try standard net address dot parse IP, not 6 actually, sorry, just IP4. I know that we're working with an IP4. We're going to use the RabbitMQ host here, and then for the port, we're going to use the RabbitMQ port. RabbitMQ port as a U16. Okay. So we're trying this too. Again, if you were building production code with this, you probably want to handle your errors a little differently. But also, if we can't connect to Rabbit, maybe we just want to fail. That maybe is fine too. So we have our address. We're parsing that. We haven't actually connected yet. So we need to say con.connect, and we're going to give it an address. So we have our address that we just created, which is pretty good. I am going to actually handle an error case here that I think may be useful. So we can just catch this. And the reason I'm catching it here is because I specifically want to print something that indicates that the connection failed. That seems like something we should be aware of. And there's a good chance that I'm going to get the connection string wrong many, many times while spinning up this Docker container. So this will help me troubleshoot that. I'm just going to use an any here. I don't remember what the error formatting specifier is. It might be V, but an any should take care of it as well. So I'm just going to say connection failed any, and then we'll come over here, and what we will do is pass in that error, like so. I guess we may also just want to go ahead and return the error here, since we can't really proceed if we haven't connected successfully. Okay, so we have connected at this point, by the time our code reaches this point. So let's go ahead and get a channel. So we can use con.channel to get that channel. And then we can declare a queue. I don't really need the return type from this, so we're just going to go ahead and leave it. You can see that it returns the queue itself, but as long as we declare the queue in this case, that should be fine. So we have a queue name, and then we need to provide some information about the queue. I want to make this a durable queue, so we're going to set that to true. And then we have additional arguments that we can pass to it. I don't really need to set any, I should say. Okay, and this can return an error, so we are going to go ahead and just throw a try in front of this. We're about to start producing, which is good. We're getting to the point where things are starting to actually happen. So I'm just going to throw this in a while true, and we're just going to run this until I tell it to stop. So we'll do a message count here, plus equals 1, so we can start incrementing that every time. We're going to create a message. So we have a message here. We need to create this struct, I guess, because I don't think we have yet. So a message will have something like an ID, which will be the message count. It'll have something like a timestamp, maybe, which will be a standard timestamp. And then some content as well. And I'm just going to make this a string that says, hello from Zig AMQP producer. Okay, so that gives us a message. We can convert this to JSON, which we're going to need to do. We essentially need to stringify this, right? Because we're just going to write the data out to a stream. So I'm just going to create a buffer here so we can do it all on the stack in this case. Have a U8, set this to undefined, and then we can grab a stream from this using something like standard io.fixed, fixed buffer stream. It needs a buffer, so we'll pass in JSON buffer, like so. Like so. Okay, and then we can do standard JSON stringify. We want to stringify the message. We want, move all that. We have options that we can pass to it, which not sure why that my LSP was showing me the wrong thing there. But yeah, so we have that message, we have options that we can provide. We don't really need to provide any. And then we have the outstream. So we'll take the stream writer and pass that in. This can throw an error. I think that in this case, if we do have an error, we probably want to catch it and handle it. And the reason why is we're in this while true loop. And if we can't write a certain message, I think we should still continue. So I'm just going to say something like JSON serialization failed. Again, we'll do an any here, and then the args will be that error. And the key thing here is we don't really want to break the loop. We just want to try again, so we'll continue. Maybe at some point we would want like a circuit breaker or something, but for now, we can just, for our little pet project, keep this going as is. So we have our JSON stringify. We want to get the message, so we can do const JSON message is equal to stream.getWritten, and then we want to publish it. So we'll take that channel and we'll do basic publish. We need to give it an exchange name, which technically we don't have an exchange. We're not setting one up. And now would maybe be a good time to mention that if you don't know about exchanges and queues and AMQP, that's maybe a video that might be fun to do at some point, but out of the scope of this video. So, look at the documentation, especially for RabbitMQ, since that's what we're working with, and I'm sure it will provide plenty of useful information to help you out with that. Okay, so we have a queue name. We have that body, which is going to be that JSON massage. And then we have options that we can pass to publish. Again, I don't think we really need any options. I think the key thing here, again, is if we catch an error, we just want to continue. Maybe we should log something too, maybe not. Probably should. We'll skip it for now. And then we can also print something like sent message number and then a digit, and then maybe that message body. Come over here, and then we'll pass in message count and then JSON massage. And then I think the last thing we need to do is just do standard time sleep. And we can do standard time nanoseconds per second, right? Yep, okay. And then we'll multiply that by interval seconds. So we'll sleep for a little bit. Okay, I think that's it. Error use of undeclared identifier on 32. Oh yeah, we haven't defined our message type yet. So let's come up here and let's create a message type, right? We will do a const message. This is a struct. We're not going to get fancy with it. No need for an init or anything. Timestamp I64 content const u8 and source, I think was the other thing. Actually, I don't remember if we added source or not. Did we add source? No, we didn't add source. I'm going to just go ahead and add a default source here. So it's more obvious where this is coming from. So in our case, it's called Zig producer. Okay, and let's not forget our semicolon. Error discard of error capture, omit it instead on 53. Yeah, okay, that's fair. Totally makes sense. No LSP complaints, looks pretty good. One thing I want to call out about this that I think is really neat, there's no allocator in our main method. We don't get a debug allocator or a page allocator, nothing like that. We're doing everything without an allocator, which I think is neat, worth mentioning at least. So yeah, I guess think about that when you're thinking about the memory footprint of your application as well. Is there a way to do this with an allocator, or minimizing the amount of use that an allocator has? It might be useful, might not. Kind of depends on the project, I guess. Understanding the resource uses of your program can be really difficult, especially in other languages that abstract a lot of this away with maybe a garbage collector. There are tools out there that can be helpful in understanding the fundamentals even if you haven't had them yet, like Brilliant.org. Brilliant helps you get smarter every day. With thousands of interactive lessons in math, science, and computer programming, you can always find something to learn on Brilliant. One of my personal favorite things about Brilliant is that it focuses on critical thinking skills, not memorizing how to solve problems. So you'll actually become a better problem solver while learning about these topics that are interesting to you. Brilliant's newly updated programming courses are a great way to get a foundation in coding, get experience with real-world applications, and learn to think like a programmer. Try everything that Brilliant has to offer for free for a full 30 days. Visit brilliant.org/codewithseibert, or just scan the QR code on your screen. You can also click the link in the description. And you'll also get 20% off an annual premium subscription. Thank you so much to Brilliant for sponsoring this video. It helps me and the channel a lot. Okay, so we have a working producer. In theory, we haven't tested it. It at least compiles, so that's something to be excited about. And the producer is actually going to be a little bit more complicated than the consumer. So let's go ahead and start to work on the consumer at this point. So source consumer.zig. Things are going to be really similar, at least how we start out. So we're going to create a reference to the standard library. So import std, import AMQP. The bane of my existence is remembering that it's AMQP and not AMPQ. I have no idea why I get that mixed up all the time, but I do. I guess P comes before Q and it feels more natural. And then again, I have taken a liking to this, so we're just going to go ahead and grab standard debug print and just bind that to print. We have a similar scenario here where we need Rx memory. And again, this is going to be 8192. And it's going to be U8 for the type. And we can just go ahead and set it to undefined. Yank, come over here, paste, and then do the same thing here, except it's going to be TX memory instead of RX memory. We need a couple more consts. So RabbitMQ host, Again, 127.0.0.1. And then const RabbitMQ port, make this a U16 5672. I'm also going to give this a type as well, just to make sure it remains consistent with expectations further down the code process, I guess. Not sure what the the code flow farther down the program. We'll also do the Q name here because this needs to match. So maybe it actually would be better to do these as environment variables just to make sure that they do match, but that's fine. We can hard code it again for now. So we have our Zig Q name. Again, we're going to create a struct here, received, RECEIVED, received message. Geez. And we want the same fields that we had in the last one. So we have a U64 for the ID. We have a timestamp, which is going to be an I64. We have a content, which is going to be a const U8. And then we have a source, which is going to be const U8 as well. Let's make a function here. So we're sending JSON over Rabbit, right? So let's make a function here called process message. So when we get a message, we can just pass it to this function and it'll take care of actually writing the message body to the console for us. It's not going to return anything. It could return an error, so maybe we should actually handle that. But otherwise, it's void. Okay, so we want to parse our JSON message, so we can do something like const parsed equal to standard JSON parse from slice received message, and we have our allocator, and then we have our slice, which is going to be message body. And then our parse options, we don't need to pass any to. I do have a typo here, so let's come back and fix that. Actually, it could be useful to catch an error here, and we can just print failed to parse message JSON, give this an any, and pass in error. Also might be useful to see the raw message. So we can do raw message. We know it's going to be a string, so we'll just pass that in right here, and then we'll pass in message body, and then we can return. Okay. We also need to defer parsed.deinit, so deinitialize it there. Const message is equal to parse.value, so we can get that message, and then do a little bit of timestamp logic here, so we can get the current time, which is standard time, timestamp. And then const message age, which is going to be current time minus message.time stamp. And then let's just do a bunch of printing, right? So let's do received message and then the number. So something like that from S, go over here, and then let's pass in message.id and then message.source. Let's do another print here. I'm going to throw some spaces in just for formatting. So content, and it'll be the message content. Let's do another one. Whoa. Print, and then age, which is seconds, something like this. Message age, and then print something like processed at, and this will be the last one we do, so we'll give it an extra line break, something like current time. Feel pretty good about that, I guess. I think all we have left to do is create our main method. So it's worth mentioning the code that we just wrote expects an allocator. So we are actually going to be using an allocator in our consumer. So, you know, maybe you can find a way to optimize that away or find a way to not do it on the heap, maybe using like a fixed buffer allocator. Fun little take-home project for you, I guess, if you'd like to make this even more performant. Okay, so let's go ahead and get, oh, I'm sorry, I don't want a GPA. I want debug allocator, standard heap, debug allocator. Yeah, that should cover it. That is a hard habit to break. Let's defer, very hard habit to break. defer deinitializing that, and then let's go ahead and get a handle on an allocator. Oh my goodness, debug allocator dot allocator. Yeah, that's going to take me some time. I've been working on that since moving to Zig 14, and I still muscle memory GPA every single time. Okay, let's print a little bit again at the beginning, just so we can verify that we're working with the correct host and the correct port. So it'll be RabbitMQ host, RabbitMQ port. And we also probably should print the queue name. So something like this. Queue name. Again, some boilerplate from the library here. We're going to go ahead and set up the AMQP piece. So AMQP init, RX memory, TX memory, more address parsing. So try standard net address parse IP4. And it's going to be the RabbitMQ host and RabbitMQ port. And I have a typo. Let's go back and add the word host. We can try con connect on that address, and then we can get a channel. So try con.channel. And then again, we can declare a queue. This is kind of interesting. So our producer is declaring a queue. It's still probably good for our consumer to also declare that there is a queue that it needs. Can help with a lot of different things, really. But one of the key ones being identifying if there's a mismatch between the queue that our producer is writing to and the queue that our consumer is expecting to read from. Okay, so we've declared our queue. Let's go ahead and set up our consumer. Actually, let's do one more print before we do that. So connected to queue S, waiting for messages, something like that. S will be the queue name. And then set up our consumer. So this is actually where things start to get easy. So we can do try ch.basic consume, and we're setting up a consumer on this queue, the queue name that we provide in. Some options. I am actually going to set one of these options to no ACK. So this is essentially auto ACK. Again, this gets into AMQP and Rabbit and all that fun stuff. But messages are expected to be acknowledged. So one thing you could do is you could read a message, process it, and then acknowledge it, or you could turn on auto ACK, which is essentially what we're doing here, which is as soon as we take a message from the queue, we're ACKing it. I'm not going to be the Rabbit expert that tells you one way or the other is better. That is, something else that you can do your own research on. But for simplicity's sake, auto ACKing here makes this a lot easier, a lot more simple to follow. Okay, so we're going to do while true, and we're just going to get a message from try consumer.next, and then we're going to call process message on it. We're going to give it an allocator, and then we have a message body, so message.body, and then we can catch an error if we want here, and probably a good thing to do. So let's catch an error, print message processing failed, and then we'll just any out that error here. Missing a semicolon. Let's add that semicolon. Use of undeclared identifier on 46. Rabbit. Yeah. Okay. Fair. Shouldn't be Rabbit host. It should be RabbitMQ host. No LSP complaints. Let's give this a Zig build. Let's see if it actually produces both of these. It does not. Our consumer, yep, totally makes sense. 45. Interesting. 45. Over here and over here. Zig build. Same issue on producer. So let's take care of that as well. Yep, right here. Okay, give this another build. Hey, that actually looks good. Okay, so we should see Zig out, ls, let's Zig out, bin, consumer, and producer. Great, we have them both. That's great, things are building. We can't actually run these because I don't have Rabbit running, right? So let's take care of that last step and get Rabbit running. So we're gonna use Docker for this, and I'm gonna use Docker compose. So I'm just gonna create a Docker compose.yaml. Give this a version 3.8. Okay, Yeah, I think that should take care of it. Let's do Docker compose up. We'll give it a build. Okay, cool. Looks like it presumably has started. So let's see private window. Okay, weird. Yeah, I'm not entirely sure what the deal is there, but we can go here, go to guest. Yep, looks good. Queues and streams. Okay, we don't have any queues. Perfect. How do we get a queue? Well, we can run zig out producer, bin producer. We should be able to run this. And you can see quite a few things. So we see sent message 1, sent message 2, sent message 3. Looks like it's going. Another thing worth mentioning, this library does some debug logging as well. I haven't found a way to turn that off. So just something to be aware of. But we can see, hey, we have a Zig tutorial queue. We have 5 messages ready. Yeah, this is neat. This is kind of going, right? So I'm going to go ahead and terminate this process. And what we're going to do is now run the consumer. So what we should see here, our messages start to stabilize at 14. Yep, just like we're seeing. I'll make this a little bigger too, sorry. Our messages start to stabilize here at 14. Once we run the consumer, we should see that those start to go away. And in fact, one of the neat things about it is how quickly this runs. It's Zig, it runs blazingly fast. Also, these messages are tiny. So there's not really much going on, but you can see that our messages in queue have dropped off here. And again, part of that is because we also have the no manual acknowledgement or the auto ACK turned on. So as soon as we start processing these messages, it gets acknowledged and Rabbit says, hey, I can get that out of my queue because someone has acknowledged it. They know that they're taking care of it. But yeah, you can see here that this is kind of working like we would expect. And there's some heartbeat stuff going back and forth, which is neat. I think one of the things that might be fun to do now that we've done this is we can run both, right? So we can start producing messages, and these will just continue to produce every couple seconds, just like before, and we can see them coming through right here. And if we really want to get fancy, we can look at Rabbit and look at the message rates, and we can see that those go up right here as well. Pretty sweet. Okay, cool. So yeah, this is a high level on how you might interact with RabbitMQ with Zig. Again, this library is, I have mixed feelings about it. It's really good in that it's very easy to set up and it's very easy to use, and it works really well. It's just missing so many things. So maybe a fun project for myself, maybe you all as well, would be to help contribute to this library and help flesh it out more. I don't know if other people use queues like I do, but they have become something I've been getting more and more familiar with due to work, and I really like them. So I could see myself using them in Zig as well. Yeah, so hopefully you found this video helpful. If you did, I would appreciate it if you gave it a thumbs up. If you haven't yet subscribed yet to the channel, think about it. You might want to. I'd love to have you here. Fun fact, this video was originally going to be on async Zig, and I just wanted more time to work on that. So I have something in the work using libxev, talking about how you could do asynchronous and concurrent programming with Zig, especially given where async is at for the language right now. So if you want to see that, I want to see that. I'm going to leave a comment below, but you should too. Let me know. Thanks and have a great day.